Hi, my name is Jonathan Hopp, and today I'm going to talk about .NET Dependency Injection, specifically the difference between transient, scoped, and singleton lifetimes, which is an extremely difficult topic for a lot of developers. It takes a lot of time before they really get the hang of it. If you don't know much about C Sharp, then I would advise taking my tutorial, my beginner tutorial specifically, which goes over the basis of C Sharp so that way you feel more comfortable. We're going to be talking about MVC apps. So if you're not comfortable with MVC apps, this tutorial might be a little bit difficult, but it's still very beneficial for leveling up and learning more about the .NET framework. Now, dependency injection. It sounds very highfalutin, and a lot of people like to pretend that it's this really complicated, deep thing. But the way I think of dependency injection is essentially this. In order to do your job, you need other things. So pretend you're like a janitor at a company, and your job is to clean the office. Well, I guess you could clean the office with your bare hands, but typically janitors require tools in order to do their job. A mop, a bucket, a broom, bleach, soap, Windex, all sorts of things that you need to do your job. And those things, are not part of you. You have to go get them, right? There are tools that you need to do what you need to do. Coding is much the same way. We don't write a program all in one file, right? Especially if it's like a really large program. That would just be insane. Most people take a large program and they break it up into a bunch of different files, and each file has its own job, right? It's like McDonald's, right? In McDonald's, you have a crew. One person makes hamburgers, one person takes orders at the drive-thru window, one person refills the fries. Not a single person should be doing everything. Same thing with code. One single block or file does not do the entirety of what the program needs to do. We break it up. Now, since we break things up, that means that some parts of the code will depend on other parts of the code. That's why we call it dependencies. So, for example, I've got my transient counter service. So essentially, this application is going to be very simple. The person is going to hit a button, and the number is going to go up. Okay, so very simple application to try to kind of demonstrate the difference between these three things. So I've got these transient counter service, and this one has an interface, and I've got three of them. So these are all basically services, and services are basically classes that have a specific job. Okay, in this case, they keep track of their current count, and then they can increment, meaning they can go up by one. Okay, they all do the same thing. Now, the service by itself doesn't do much. Okay, our application says, okay, cool, the service, it handles the counter, but then what do we do with the service? All right, so we have the counter controller. The controller's job is to receive requests from the internet, right? So from where it gets requests from out in the outside world, and then it does something with the request. So when the controller receives a request, .NET says, cool, I got a request. I'm going to spin up a controller, a counter controller. Because remember, this is object-oriented programming, so the controller is an object. And so we're going to instantiate or create a new one. Now, the controller needs the services to do its job. Again, the controller is a janitor. It cannot clean the building without the mop and the bucket and the broom. All right, so who's going to give it the mop, the bucket, and the broom? Who's going to provide these things to the controller? That is a dependency injection container that comes with .NET. So .NET has its own DI container. If you use Java, you've probably heard of Spring. All right, so there's this concept generally that we need some sort of device inside of our framework that knows, hey, this controller depends on these other classes. I will make certain that when the controller comes into being, it will get all it needs. When the janitor starts his job for the day, he'll have someone come by and say, cool, hey, Joe, I stocked up the bleach and the soap and the broom and the mop and everything. You're ready to go for the day. In .NET, what we do in order to register our dependencies or basically say, hey, these are things that other things depend on. We go to program.cs. We start our application with Builder. Most of this code is already going to be done for you when you make a new MVC app. You don't need to write this. But the part that you probably haven't seen yet is services. So we have builder.services. And then we have three different methods: add transient, add scoped, and add singleton. So what all three of them do is they let the dependency injection container know, hey, this is a thing that is a dependency. Other classes will need this to do their job. I need you to be aware that these things exist and how to make them. Right? Now, the DI container there's a lot of magic in the behind the scenes that you don't need to worry your head about, because as long as you tell it, hey, here's my concrete class, and typically you're going to give it an interface to work with, it will handle the rest from there. Okay, you don't really need to totally worry about all the details about how it gives the controller its dependencies. It doesn't even have to be the controller, it can be anything. But you register your dependencies using this syntax. Then how does the controller get the dependency? Through the constructor. Okay, it's not the only way to get dependencies, but this is the one you're going to see 9 times out of 10. Notice how I have public counter controller. This is the constructor. Remember, when that request comes in, the controller will be instantiated. It will be created. When it's created, you're saying, hey, this controller needs a transient counter service. It needs a scope counter. It needs a singleton counter. Well, the DI container will look at this, say, hey, this interface looks familiar. I wonder what this means. It will go back to here and say, oh, this interface corresponds to this concrete class. I'll go get me a new one of this transient counter service and go hand it off to the counter controller. That's it. So it doesn't need to be more complicated than that. I know there's inversion of control and handing off control. It's very, very complicated for new programmers to get into this. All you're really doing is saying the counter controller is starting his job. What does he need to do his job? It's at the beginning of the workday. Here you go. So now the counter controller will get all the services it needs. This is a common pattern. You bring the dependencies in through the constructor. You'll have a private variable for each one of them. I have private read-only transient counter service. And then for each one of them, I just basically take the private variable and make it equal to the incoming dependency. This is an extremely common pattern for dependency injection. You're going to probably do this hundreds of times during your career. Now, why do we have transient, scoped, and singleton? Okay, why do we have these 3 different lifetimes here? Like, if a dependency is a dependency is a dependency, why make a difference between them? Well, dependencies, once we make them, remember, when that controller gets started, we make a new counter controller, we say, okay, cool, here's a transient counter service. Well, wait a second, I've made a new transient counter service. How long should this service last for? Okay, when should I destroy it, or should I destroy it? Because the DI container's other job is to keep track of what dependencies you currently have running. Okay, you can think of it like spinning plates. It starts at the dependency, it starts at spinning plate. It's like, okay, cool, when do you want me to tear down or get rid of this dependency? And you're thinking to yourself, well, Jonathan, should it just last forever? Well, it depends on how you as a programmer get to have a little bit more fine-tuned control of how long the dependency exists. So here's a little infographic to help you kind of visualize what's going on. So a request comes in from the client. The controller receives the request. The controller says, okay, cool, I have these dependencies I need. And so the dependency injection container says, okay, cool, how long should these services last for? Are they going to last for the entirety of the request, from the beginning to the end of the request? Should they be shared across different parts of the app through the request, or should we just make a new one every single time? Or maybe we should only have one of them, right? So maybe we should have this one service and we're not allowed to make copies. We're only allowed to have a single one. So I'm going to have 2 different examples. The first is going to showcase the difference between singleton and the other 2, scoped and transient. Then I'll have a second example to go more into the difference between scoped and transient. Scoped and transient are very similar, and it's very easy to get them mixed up. However, singleton and the other 2, the difference between them is pretty stark, so we'll be able to notice a difference pretty quickly. Singleton is basically you only get one. There is a singular, unique service. You get one of those objects, and that's it. You're not allowed to make copies of it or duplicate it. You get one copy of the service, and everything points back to that singular copy. Whereas scoped and transient, they will make a new one on the request. Still confused about what I mean? Let's actually take a look at an example, and once you see it with your own eyes, I think it will make a lot more sense. All right, now I'm back in my application, and of course the GitHub link to this repo is down below in case you would like to take a look at it later. But in program.cs, I've added a transient, scoped, and singleton service. So that way we can kind of demonstrate the difference between the lifetimes. So again, I'm going to focus on the difference between singleton and the other 2, and then we'll get into the difference between transient and scoped. Singleton is a pattern, it's a design pattern. It essentially means one, it's like the Highlander, okay, like that really old show where it's like there can be only one. All right, so what I'm saying is that this Singleton counter service, there will only be one instance of it. Okay, I'm going to instantiate the Singleton counter service, and there will only be one. We will never make a new one. We will never destroy it. It will just be the one, and that it stays there, and that's it. Okay, it doesn't matter about the request. Transient and scoped, they will last as long as the request lasts. So once the request is done with, so remember, we get the request in the controller does some mumbo jumbo, and then the request is eventually finished. We're done processing it. When we're done processing it, we're not going to have the transient and scope services anymore. They're going to be gone. Now, you're like, what the heck are you talking about, Jonathan? All right, let's go to the controller, and I am going to go ahead and run the program. All right, so here we go, counterexample, and now I'm showing you the state of each of the different services. So the transient counter service, the scoped counter service, and the singleton counter service. When I hit this button, notice how they all go up by 1. Makes sense. When I hit this button again, notice that only the singleton goes up by 1. The other ones stay at 1. And it doesn't matter how many times I hit this button, the singleton is the only one where the number is actually going up every time I hit this button, whereas the other two are just basically at 1. What's going on? Keep in mind, when I hit this button, I'm making a request to the controller. Here's the controller, and I have this increment method, right? It's an HTTP post, and this is what happens when I click that button. So when I click that button, I want you to take a look at something. I've got my transient, scoped, and singleton services. Okay, so I'm going to do a little bit before and after. I'm going to show you their value before, then increment them, then show you after. All right, so I'm going to go ahead and make a request. So I'm going to hit this button. All right, and now notice how the transient count is 0, 0, and singleton is 6. Why? When the request comes in, it makes a new transient counter service, and it makes a new scope counter service. But singleton, there can be only one. We're not going to destroy this thing. We're not going to remake it every time we get a request. There's only one. They all refers back to the same one. So that means after I increment, put a debug point here, then notice how transient count went up by 1, scope went up by 1, and then also with the singleton. So when I continue, the UI will update. And I'm going to hit this again. See how transient count starts back at 0? That's because it's a new transient counter service. Okay, so this object is transient counter service. It's basically like they did new transient counter service. Well, when you do a new one, it starts back off at 0. Same thing with scope. Every time we get that request, it's going to be like, hey, I want a new one. With singleton, it's not going to make a new one. It's going to say, hey, I already have one. You need to go use that one. All right, so singleton, all right, is great for any time we want to have a dependency where we only have one of it. This could be great for like configurations, like for example, you have like a configuration that says like, hey, here's where the database is, and here's the API key, and here's a bunch of other stuff that your program, like secrets and things like that. That doesn't change based on the request. Like, it doesn't matter like what request comes in. The database connection string is a database connection string. The API key is the API key. So those sorts of things where I don't really need a new service every single time someone makes a request, then singleton is for you. So that is why we're able to, for example, with this counter, this number, every time we hit this button, let me hit continue on here. Let me get rid of these debug points. We're going to hit continue. Okay, that's why when we do this, we want to be able to like remember the number, okay, across requests. And then that way we are able to keep track of that. So this singleton will be able to keep its state no matter like whether the new request comes in or the request is finished. Whereas with transient and scope, when the request comes in, we're getting a new scoped counter service and a new transient counter service every single time. So you might be thinking to yourself, well, Jonathan, like, what's the actual difference between transient and scope then? If they're made new every time we get a request, like, what's the difference? Why would you have, like, two of them if they only live as long as the request lives? Well, I got another example that will kind of showcase the difference between the two of them. All right, in this other project, and again, the GitHub link is down in the description. I've got two different projects. So here I've got a shopping cart service. So like picture like an e-commerce platform where people are, putting stuff into their cart and checking out. So we have a shopping cart service, and the shopping cart service's job is just to keep track of what's in the person's shopping cart. I made it real simple. You can only add products to your shopping cart, and you can get all the products from your shopping cart. Then we have the checkout service. The checkout service's job is to say, hey, it's got a dependency on the shopping cart service. So notice how here I'm injecting the shopping cart service into the checkout service. So the checkout service is dependent on the shopping cart service. Without the shopping cart service, the checkout service cannot do its function. It cannot do the thing it was born to do, which is to in this case, give me the sum of all of the items in the shopping cart, and then add a 6% sales tax. All right, so the checkout service, its job is to say, hey, give me a shopping cart. I'll tell you what the total of the shopping cart is, and I'll apply tax to it. Okay, now in this case, whether or not we make either of these services transient or scope will make all the difference as to whether or not our app will work. So in program.cs, you'll notice I have builder.services that add scoped, and then I have the shopping cart service, the checkout service, and then the interface that goes with each one. If we go to the cart controller, these are its dependencies. So I have the shopping cart service and the checkout service are dependencies. The cart controller requires them to do its job. So we inject the dependencies into the constructor. This is a common pattern, injecting them into the constructor, having a private read-only variable, setting the private read-only variable to the incoming dependencies. Practice this. I've done this thousands of times throughout my career. This is a very, very common pattern. Now, on the main page, just to keep things simple, I simulated what it would be like for someone to go shopping. So when the page starts up, we'll add a few products to their cart. Then we're going to showcase like what products are in your cart, and then what is the total cost of everything in your cart, including tax. So let's run this. Now this looks pretty normal, right? Shopping cart demo. I've got a peacock hat. I've got a top hat with a monocle. All right, and then my total cost, including the 6% tax, is $47.70. Well, that makes sense, right? So how did it arrive at this? Remember, I have my checkout service. So if we go to checkout service depends on the shopping cart service. So I'm going to go ahead and put a stopper here, and I'm going to refresh the page to make a new request. All right, and so the debug point stopped here in the checkout service. So I'm going to hover over products and see that there's two, right? So I've got two products, the peacock hat and the top hat with a monocle, and then it will give me the total cost and multiply that by 0.06. And that way I will be able to get the total cost of the items in my cart. So this looks correct, right? This looks normal. Let's see what happens when we change these services lifetimes from scoped to transient. I'm going to do that. I'm going to stop my app here, and then I'm going to go to program.cs. And I'm going to comment these out. All right, so, and then I'm going to uncomment these ones. So now instead of doing add scope, I'm going to do add transient. And I'm going to go ahead and go to checkout service. I'm going to put a stopper here, and we're going to run it. All right, let's take a look at what our shopping cart service says. There's no products in the shopping cart service. Well, wait a second. That doesn't make any sense, because now when I go back to it, now it says my total cost is 0. What the heck is going on here? All right, because that's clearly wrong. So it might be very confusing because here, right, we have a shopping cart service and we added products here. So for example, if, let's go here, I'm gonna put a breakpoint here. I'm going to refresh to trigger it. Okay, so I'm going to take this view model. And they're here, right? This shopping cart service got the products added to it. And I mean, there's the hat and the top hat with the monocle. So why is the checkout service giving me the wrong number? Because if you go into the checkout service is not getting the same instance of the shopping cart service that the controller is getting. I'm going to repeat this. The cart controller gets a shopping cart service. And the checkout service also depends on the shopping cart service. Because the shopping cart service is transient, okay, I put transient here, That means that every time we inject the shopping cart service, we always get a new one. It's always in the background going to do new shopping cart service. Well, if you do new shopping cart service every time, it starts off with nothing in it. It's blank. All right, so that means that the shopping cart service that the checkout service receives and the one the controller receives are two different instances. So that means that the cart controller's version of the shopping cart service does not get over to the checkout service. So that basically means then that the checkout service doesn't have anything that happened in the controller. So we get this bug, right? I have these in my cart, but the total cost is nothing. Whereas if I change it back to scoped, which I'm going to do in a second. So let's stop this. I'm going to go ahead and change them back to scoped. Okay, and I'm going to make sure we have our breakpoint here to kind of show you what's going on. So I'm going to go ahead and rerun it. So when I rerun it, it says 2. That means that this instance, okay, this shopping cart service here, this service here, this object that was injected into the checkout service is the same as the one that was injected here for the cart controller. That means that the cart controller and the checkout service both get the same shopping cart service. It's scoped the request. That means anything in my app where this shopping cart service is injected will get the same one. If it's transient, they all get new ones. So as you can see with this example, that actually matters quite a bit. If it's scoped, because that means that the cart controller and the shopping cart there will affect the shopping cart in the checkout service. So I want scope because multiple parts of my app are using the same service, and the state of the service, meaning what products are actually in the cart, that's the state of the cart, matters. It's got to transfer from one part to the other. If it's transient, everybody gets a new one. It starts fresh every single time. So scoped is good when the state of your request needs to be spread out among your app. If it doesn't, if you just want a new one every single time, then you use transient. So the difference between scoped and transient, I think, is the hardest one to get, but hopefully this makes it very clear. Thanks for watching, and I hope you learned something about the difference between scoped, singleton, and transient lifetimes. The dependency injection container in .NET is very difficult to understand. It takes some years of practice. It took me a long time before I got it. So hopefully this tutorial would wipe away some of the confusion. If you like this video, of course, please like and subscribe. This channel is all about teaching people how to code. I would love to take my knowledge of coding and help people become self-taught developers. All right, it's a brand new world out there, and you can teach yourself how to code. Also, please put in the comments if you'd like to see what other topics you'd like to see. Maybe you have other things about .NET that you're curious about and would like to learn more about. I would love to hear about it in the comments. Catch you next time.